Okay, today is the last section of the transformations, and today we're going to go over dilations. So our vocabulary is dilations, dilation factor, and center of dilation. A dilation is a transformation that creates a figure that is proportional to the original. In a dilation, orientation is preserved, but size is not preserved. It's the only transformation where size is not preserved. So you have a center of rotation here. And let's see, since that's A and this is A prime, you can see that this was the original figure here, and that's the dilated figure. And we know that the blue figure is smaller than the green figure, so that the dilation factor must have been a number between 0 and 1. So it was some sort of fraction. What we know about a dilation is you need to have a center of dilation. Oops, I should say dilation. In a dilation factor. A dilation factor will be the ratio of how big the corresponding parts of the new figure are to those of the original. So let's say that I were dilating this original triangle by 1.5. What I would do is I'd make lines that connected these points to the center of dilation, and I would extend them. So there are these lines right here. And then if my dilation factor were 1.5, it means that I would measure the distance between the point and the center of dilation, and I would go 1.5 times that distance. So that's about, just estimating it here, that's 1.5 times that distance. And then there's the distance from the center of dilation to B, and so along the same line I would go about 1.5 times that distance. And again, that's from the center of dilation to C, so I'd probably do about, there's C prime, and then I would connect the figures here, and I'd have this larger triangle right here and the smaller one from where it came. And what I know about dilations is that when I look at the corresponding sides, so the side AB and the side A prime B prime, since the dilation factor is 1.5, I know that side length AB, you need to multiply it by a factor of 1.5 to get the measure of side A prime B prime. Likewise with the other sides. If I were looking at BC, I could multiply that by 1.5 to get B prime C prime. In other words, B prime C prime is 1.5 times BC. Okay, we can say that about all the sides. So this side and this side are 1.5. This side you have to multiply by 1.5 to get this one multiply by 1.5 to get this one. Okay. So let's say that we're asked to dilate a figure, and by the way, you're rarely asked to dilate in this manner. You will be asked maybe in a geometry class in high school to dilate in free space, but typically in 8th grade you're going to be asked to dilate on a coordinate plane, which is really nice. And usually in a coordinate plane, the center of dilation is the origin. Okay, so we mark that as the center of dilation. And the way that we dilate, because the origin is the center of dilation, we dilate using the coordinates. So since G, if we look at the original G is 7 units across and 6 units up, and that's the distance. G is that position, 7, 6 is the distance G is from the origin, and we want to take half of that distance. What we can do is, since that's G, we can take half of all the coordinates. So G prime will be 3.5 and 3. Okay, so let's find G prime here. 1, 2, 3.5 and 3 would be right here. That's G prime. Okay, likewise, H prime would be 3 and 1. So H prime would be 1, 2, 3 and 1. There's H prime. And I prime would be 3 and 2. So I prime would be 1, 2, 3 and 1, 2. That's I prime right there. And F prime would be at 1.5 and 2.5. So 1.5, 1.5, and 2.5 would be right at the middle of that box right there. That's I prime. I know it's not a very nice drawing, but oh, sorry, that's F prime. That's F prime. So if I connect these dots right here, F goes to G, G goes to H. What did we say H was? 1, 2, 3. Okay. We should have a figure that, my figure's sort of messed up, but we should have a figure that's smaller than the other one because we dilated by a factor of 1/2. I think we're a little off here. My H was a little off, I think. But this should be about what it looks like, okay? So it should be about 1.5 times what, or half times what the other one is. And what we know about that, again, that the side lengths, when you, the corresponding side lengths are, you would have to multiply this side length by you'd have to multiply this side length by half to get to the original side length. You have to multiply this side length by half to get to this one. Likewise with this one, and this one, and this one, and this one. Okay? If I were to dilate a figure by 2, I would take the coordinates that are there, and I'd multiply all of them by 2. So J prime would be 2, 8. K prime would be 2, 12. L prime would be 4, 8. M prime would be 6, 8. And N prime would be 6, 6. So, okay, so I paused the video so I could plot all those points and you could see them. So the figure that I have, oh, it looks a little, oh, actually I don't think I connected them right. So let me pause the video and connect them right again. Okay, I think this is right now. So if you can see that J prime, K prime, L prime, M prime, and N prime, I just plotted all the points that are down here, and you can see that when you look at the corresponding line segments, so JK right here is twice the length of J prime, K prime, rather, is equal to 1, 2, 3, 4. It's 4 units, whereas just JK is equal to 2. MN likewise. MN used to be 1 unit, and now MN is 1 unit, but M prime, N prime is 2 units. Okay, that's what it means to have a dilation factor of 2. It means that every line segment is twice what it used to be. Okay, and finally, let's dilate a factor by 2.5. And really all that means is taking the coordinates and multiplying them by 2.5. So O prime would be negative 4.5 and 2.5. P prime would be 2.5 and 5. Well, actually, that's what this should be too. It should be negative 5, right? Negative 5. And Q prime should be 5 and negative 5. And then finally R should be negative 5, negative 5. So I'm going to pause the video one more time to get this all plotted so I can bring back to you. Okay, so I've plotted all these points and I've connected all these lines, and you can see that this quadrilateral, the smaller one, sits inside the larger one. And if we just do a quick check here, let's look at side lengths, corresponding side lengths. So OR is 3 units. Right there is equal to 3, but O prime, R prime is equal to 1, 2, 3, 4, 5, 6, 7 and a half. And if we take 2 and if we take 3, multiply it by 2.5, so that 3 times 2 is 6, and then 3, so it's like taking 3 and multiplying it by 1 plus a half here. So 3 times 1 is 3 plus 3 times a half is 0.5. So that's, by 2.5. So this is 3 times 2, which is 6. And 6 plus 1.5 is 7. I made a lot of mistakes on that one. Let me just try that one more time. 3 times 2.5 is the same as 3 times 2 plus 1/2. 3 times 2 is 6, plus 3 times half is 1.5. So 6 and 1.5 is 7.5. So that makes sense. Okay, so just a quick check. This is 7.5 long, this is 3 long, and 3 times 2.5 is 7. So the dilation factor is 2.5. Okay, and the other one sits right inside of it because the origin is in the center of that quadrilateral. So it's the larger one just moves out from the origin in all directions. Right, and that's the end of the video.